Hello. You guys hear me? Okay, is that good? Hello. All right. Cool. I think we're online.
And it's great to have you. I might need your mic to be on, and I'll just do a quick test.
Great. Can you hear me?
I can hear you.
Okay.
Brilliant. I will let you take it away and share your slides, but thank you so much for joining us. We appreciate your time. I'll be collecting some questions, and after you've finished your talk, I'll rejoin to ask some of those. But thanks again, and feel free to share your slides and take it away.
All right. Thank you. And thanks, Mike. And thank you, everybody, for dialing in. This will be the first time I'm speaking at DroneSec. And a lot of our sharing we're going to do today is based on our experience in Singapore, in Southeast Asia, and hope it's going to be useful for everybody's sharing. So I'm going to focus a lot about internet-connected drones because that's something that's kind of close to my heart, and we have been trying to push out internet as the kind of the backbone for drones. But before I start, maybe I give a quick introduction about our company. Garuda Robotics, we are an AEO company. We're based in Singapore. We have presence in Malaysia, but we also fly pretty much everywhere in Southeast Asia and South Asia as well. Our business is organized into three different segments, right? So we are on one side, on the left side, you have the fly safe product teams who look at BVLOS as a very important capability, and we were active in doing inspections, deliveries. We build command centers, and we also organize a lot of training and compliance consultancy for customers. In the middle, you have our GeoSmart team, who is very much focused on the artificial intelligence side of things. We have built applications from facilities management, smart cities, and plantations, and so on. And we use geospatial technology as well as AI, machine learning, computer vision in order to get our drone data analyzed. And on the right, we have a business around security, specifically around homeland security, to help airspace management for the regulators, as well as cybersecurity. And this is kind of the focus of today's topic. And in general, other kind of homeland security use cases like delivering an AED drone to a cardiac arrest station. Now, this slide is just to kind of motivate why we talk about internet-connected drones. It's in my opinion, it's an inevitable outcome, right? So the fact that the drone industry today it's so vibrant and there's so many players, it's also partially driven from 10 years ago. We started adopting mobile-based technologies, right? We have GPS becoming so cheap, and all these iNews, MEMS chips, and all this becoming so affordable that people could just slap it onto a drone and start flying, and you end up with many companies being built around these use cases. Why not go all the way, right? So to put a SIM card on a drone, basically, is what we say. So these are numbers I took from GSNA, and apologize for those who I borrowed quite a bit of pictures from different slides and studies. But so GSNA published a study I think just last year, right? And these are some of the numbers they said, right? So a lot of drones, specifically they estimate to be 6.5 million drones by 2025 will be connected to the internet in real time, right? And a lot of it will going to be in logistics and transportation, public sector, and so on. The ones I dotted up is the ones that we play, and we have a lot more information about, and the products that we have kind of built around these internet-connected drones. And this is not kind of a first day, right? I mean, I guess we have been trying to do this for the last 5 years, and these are some of the examples of ourselves as well as some of our partner companies in Singapore who have been flying some internet-connected use cases, right? An example will be we'll be working to a hospital called Parkway Pantai to try to do like delivery of blood samples. Another example will be the maritime logistics, which I think last week we did a bit of a launch of a maritime drone estate with a couple of other companies who are saying that we're going to use this maritime drone estate to do shorter ship deliveries. At the same time, we have the first responder side, right? We created a system called Garuda Responder, which is to deliver AEDs, but also other kind of emergency medical devices. Again, controlled via the internet, right? Or for incident response, we have a product together with a partner, Flight Dynamics, to do perimeter patrols as well as respond to incidents like fire and so on, coverage. During the last year's lockdown period, we've been helping government customers to do safe distancing by connecting, again, drones directly to a cloud and running computer vision algorithms to find where are people crowding up to prevent all the virus from spreading and so on. And last but not least, we've been working with MNOs like Intel, where we can try to do something called UAV hardware tracker to track drones as they fly, to give the regulators a full vision of the airspace, right? So this is basically something related to the upcoming topic of remote ID. So how do our products kind of look like? Just to give you a sense of it, we've been putting cellular technologies onto both, all three parts, right? So on the left, you have the tracker, and this is kind of the current version of it. They're still miniaturizing it at 50 grams. It is a self-inclusive, it's complete in itself, right? So it has its own IMU, GPS, 4G connection, SIM card, so on. And it can transmit basically securely, right, the position of the drone, whichever drone you kind of stick on, right, to a regulator or to a UTN provider and so on, right? The middle picture you saw there is just an onboard computer. I think many people are building these such onboard computers. Ours will be building it with two modems, one 4G, one 5G, because there's quite a bit of 5G projects being rolled out this year. We are trying to get into the market to help customers understand how to connect via 5G, and as well as internet connected drones itself. That means out of the box, you kind of buy drones from us that already have this cellular connectivity. So the talk for today, I'm going to go from the left to the right. So we're going to focus a lot first on the hardware tracker that you see here, which is turns out to be quite contentious. I was surprised, right? So when we started doing this tracker about 3-4 years ago, when we look at it, it's like, it's no brainer, right? We should just be able to just put a tracker and put a SIM card and be done with it. Well, it turns out that there's a large community around the world talking about this whole idea of a remote ID, right? Essentially, what we all want eventually, right, is to have an equivalent of a car plate. Every country in the world, every car has a car plate, right, of some sort. You don't know who drives the car, you don't know where the car is going, but when the car does something that's not supposed to do, you have a car plate number, you can call the police and say that car just banged into me and the ID is so and so, right? So fundamental to any kind of management of airspace, it's basically the ability to identify any object, right? So this was taken from one of the latest versions of the documents, the picture, I mean, right? That basically stipulates that these are the two possibilities for us to actually have a car plate, the equivalent of digital license plates for drones. Now, you can't have the same equivalent physical plate because the drones are so far high in the sky, you can't really see it with your eyes, right? And we don't carry binoculars around. So we tend to use some form of a remote radio frequency, right? So you have the first case where you have what we call the broadcast remote ID or broadcast UAS, where you will use technologies that's kind of common to all our mobile phones today. Bluetooth, Wi-Fi, there's this technology called Wi-Fi aware, which all the devices like your Apple, your Android, and so on will be able to just connect to it and receive certain information about the drone. What is its latitude, longitude, an ID of the drone, what is velocity, and potentially even like whether it's in an emergency mode, it's actually trying to come down because it's not doing well, and so on, right? And then you can kind of verify whether this drone is really saying what it's supposed to say, because there might be attempts to spoof that information. On the middle side, there's this more complex architecture, right, which is this network remote ID or net RID, they call it, right, where either the drone or the GCS is the ground control station, right, the app or the transmitter that controls the drone for the pilot that's standing on the ground, would share that information via the internet, right? So maybe via the mobile phone's internet, or directly on the drone itself. You kind of put a SIM card there, right? To the cloud, some provider, right? In this case, the Envision provider is what we call a UAS service supplier, USS, right? And through some very complex and very how do I put it? Very secure, right, way of passing the information, that information eventually still pass on to the user of the mobile app on the right, right? And of course, there's a third kind, which we won't focus much today, is basically to say that there could be also other ways to know who is flying if you ring fence a place like the university or a school, where the students are only the ones in the school flying, so it's fine. You can just let them go and don't have to force them to build a broadcast or a network device on it. On the right, you have basically the public, the law enforcement people. A lot of people are interested about who is doing what with a drone, right? So everybody wants to get the telemetry. partially also because I think from my perspective, right? I mean, I grew up with this website called Flight Radar 24, and I really like to just go to the website and watch planes fly, right? Because planes they do broadcast their location using a technology called ADS-B, Automated Dependent Service Broadcast, which allows us to see where every drone is and can kind of follow where, like my parents are flying to Singapore, I can follow the plane and know whether they're arriving. So I thought it would be a very normal thing again, right? That everybody just share what they're doing. But it turns out that that's not the truth, right? A lot of people are actually not comfortable at all sharing where they are, what they're doing to people they don't know, right? Which brings me to this kind of a spectrum, right? So during the whole proposal for remote ID, there was strong proponents on the left, which is for the broadcast remote ID, and there are strong proponents on the right, which is the network remote ID, right? So if you look at the left, which is the broadcast only side, and we'll dive in a bit later. Right? So this is the current latest status from FAA, right? So FAA by the beginning of this year finalized a ruling around this, and together with ASTM, they have this standard called F3411-19, where it basically just says forget the network flight, just do the broadcast one, right? So you just have either Wi-Fi broadcast, Bluetooth broadcast, either your drone broadcast or your you have an attached UAV hardware tracker that you broadcast onto it. Now there's a lot of pros to this, right? It's cheap, it's independent. You don't have to like rely on a subscription of some sort. There's no single point of failure and so on. And we'll dive into the pros and cons in the next few slides. And generally the cybersecurity risk is low, right? That means that if you're flying in, say, Arizona, right, you need a guy in New York won't see you, right, because your broadcast is not going to go so far. But at the same time, from a regulator standpoint, you don't have a full airspace map, right? Or if you are just like your local airspace manager, you don't know who is doing what still until you are in the same vicinity within 100 meters of the drone, then you can get the RF information, right? On the right, you have the network-only guys, right? So those people who are saying that, okay, use the internet, but the internet is a dangerous place. We all know that, right? So mainly you have to pair it with some sort of VPN or some central control, right? The hope is that there's some benevolent dictator who would take all your telemetry data and not do anything bad with it, right? You have basically then the full airspace information all coming through the cellular network. And you can do a lot of additional things, like you can deconflict, right? The use of airspace, like you have permits for this airspace, you get to go first, and the other guy have to wait, and so on. So this is kind of the basis of traffic management in the future when the airspace become more dense, when all our food is delivered by drones and parcels and e-commerce and so on, right? The cons, of course, is that if this information starts flowing over the internet, it basically inherits every single risk profile of the internet, cybersecurity risk, right? So you have to kind of design it properly. In the EU, for example, they say that broadcast is going to be mandatory, but network is optional, because I think without network RID, you can't do things like beyond visual line of sight operations and some of the advanced UTM use cases. So let's take a look, since this talk is more about cybersecurity, let's take a look at what the Americans say, because I think they were really, really against this whole network idea. So this is a picture I took from FAA's website, right? So this is the final decision, right, from the government. You can basically fly RID on the drone or RID on the broadcast module, or go to an area where you don't need RID, but FAA recognized that that area is actually a FRIA, right? They recognize the ID area, so you don't have to fly with the RID. But if you look on the right, this route, I mean, FAA did a good thing, like they published literally everyone's feedback, right? And when I read that document, I was surprised. It's like, what, 20, 30 pages of people just saying no. And these are things they brought up, right? What if there's a distributed denial service attack on the RMB USS? So basically the servers that aggregates your telemetry, right? And once the data goes there, then it's I mean, you can say that it's secure and so on, but the data is kind of owned by RID, right? By the USS, right? So this is very, very much driven by people's fear today. Like a lot of data is aggregating with a few big tech companies like Google, Amazon, and so on. And would that same situation happen in the drone world, where all the telemetry actually goes to a few USS companies, right? And also bigger countries like I mean, say US, right? There's many places with just no coverage, and there's many little drones with actually some form of a network coverage device, right? So it's expensive to put in place, and if once you connect it to the internet, potentially the information might also go into some adversarial country. right? There is potential hacking or spoofing or and so on, right? So you can go, you can read the rest of it. And in general, the end of it, I think the one thing that kind of make or break it is that just doing this across a large country like US is just 5 times more expensive to ensure that every single part of the country has cellular networks and every drone has cellular connectivity, right? Now, when I read through this, I felt that, look, those are all reasonable requirements, and I think that as a large country and a large place with deserts and large sorts of forests, it makes sense that broadcast would be the de facto way that you kind of do remote ID. Where even as the central FAA would not have the full airspace picture. However, we as a company, as we develop these technologies, we also relook at our own situation, right? And we also relook at where the entire drone industry is going forward. We felt that without network RID, you can't enable more advanced use cases. So one simple example would be just to look at all the beyond visual line of sight use cases, right? To do drone delivery, to do surveillance, right? To be able to know where your drone is all the time, your drone is going to be connected by something, right? So you need basically some network. It could be cellular, it could be satellite, it could be anything else, right? But basically, if you cannot stay in control of the aircraft at all times, you cannot enable BVLOS. And the fact that you are connected means that the identifier or whatever you are doing is already coming back through some connectivity, right? The other issue we find that is that if you look at the broadcast specifications that eventually got selected, it was not some special aviation band. It was just your Wi-Fi. It was just your Bluetooth. All of them, they operate at the ISM bands of 2.4 gigahertz, which is very, very crowded, and there's a lot of interference. So if you live in Singapore, to our international friends, you will, like when I turn on my laptop, the list of access points available is in the hundreds. It's just that many access points and that many different devices trying to connect and try to fight for that Wi-Fi range. That sometimes I feel that if you're going to implement this broadcast RID in again another crowded city like Singapore, it's going to be some issues when you reach a certain amount of density. The third point was interesting because I was having conversations with a number of people in the industry in Singapore, and one of the points that was brought up was not every drone wants to tell you where they are because they are doing something important or secret. So if a police drone is trying to silently come around you or do some surveillance, they are not going to be broadcasting the RID, but they would definitely be happy to share that network RID with, say, for example, a national level UTM system, right, which is also controlled by, again, for potentially the military or the aviation regulator, right? So if you have only half the people or most of the people sharing your telemetry information and some don't, you still don't have the full airspace, you still cannot do the deconflict. And last but not least, we actually felt that there's a lot of work that needs to be done in the standards currently to address all the cybersecurity concerns around the protocol, right? So which brings me to the next slide. I went around to prepare for this talk. I went around to look for who has been kind of the proponents, right, of network RID. And what are the major things that they think about when we talk about network, right? So I found a few, again, GSMA published another nice document that responds to the ASTM F3411 document, which I picked some of the pictures from. But I think that the concepts are pretty similar, right? So there's a concept of you really want to preserve the operations privacy so that although you see a drone that's flying via your app or something, you shouldn't know what the drone is doing, right? All you need to know is that there's an ID. If anything, you have a complaint, you have some recourse, basically. I have to say that there's a drone outside my house and it is ID 123. You call the police knows who ID 123 is. They're going to find the pilot and get the pilot to stop being a peeping Tom or something, right? So that kind of ops privacy is important to be confidential, but at the same time allows for the ID to be easily read by anybody. The second part is basically that a lot of comms channel encryption is pretty straightforward. I think it's kind of sad that like ADSB protocol, for example, is not encrypted. But most of the internet-based communication should be encrypted by now, right? So most browsers ignore HTTP by now. You have to have HTTPS. We all use TLS and so on. And on top of that, because if you tag yourself to the cellular network, right, The cellular industry also comes with something called the IMEI, right? So International Mobile Equipment Identifier, which is another identifier which you can use to identify the aircraft. So if you pair it well, and also the SIM card itself also has an identifier, ICCID, which if you pair it well with the system, if you design it right, you can use that as a very good way to identify and authenticate that is indeed that transmitter of some sort that's providing the information. And thirdly is this important other part, which is for transmission to happen, you have the mass market side, right? You need the infrastructure to support the entire country, right? Again, that's why the proponents for bigger countries would say that, I don't have coverage. In the case of Singapore, we have pretty much every single corner covered, right? So, and there's a committee around the world called 3GPP that's setting standards. So there's going to be a lot of devices that you can slap on the drone, which is affordable because of the massive scale that the cellular network can get to, right? And looking at existing aviation technologies like ADS-B and all this, it's just a no-go. The way it's designed is going to be flooding basically the entire frequency, and we won't be able to handle every drone having an ADS-B out transmitter. But that said, given all these design principles, there's still a lot of questions that need to be addressed. This slide just gives you a framework of how to think about these are the challenges. Again, using the existing framework of using multiple UTM service providers. Right? So for example, if there's it's a pilot one who flies drones ID1 connected through some mobile network and from the operating center, and you connect it to some UTM service one and so on for node two, right? So what exact information then do you need to exchange? Do you need to just exchange the ID, or you need to exchange the ID and the location, or the ID and the location and the velocity? Like how much information do you actually have to share in order to know what the other guy is doing? Again, let's connect that back to the land transport, right? You can see a car, you know how fast the car is going, right? Just look at it, right? And the car is going way too fast. You look at the car plate and call the police and say, this car is speeding, okay? So pretty straightforward, but how do you do it in the drone world? And let's say the drone ID1 and drone ID2 is about to collide, right? Who decides who to give way, right? It's not so easy in the sky to say, okay, keep left, right? I mean, you can, right? Or keep right, right? Or depending which part of the world you are at. But somebody has to give, right? Somebody's going to go on, the other one's going to have to wait, and so on, right? Who is the decision maker ultimately if there's multiple UTM service providers? And there's also these two things. The mobile network is actually sitting in the middle, right? Are we just treating mobile networks as dumb pipes, or is there something else that we can do in the mobile network that can enable the privacy, confidentiality, and integrity of the drone data? What if it's a hacker who connects to the mobile network to provide spoof data, right? And last but not least is, given UTM service provider 1 and 2, how about law enforcement, right? Would they then send the information to the law enforcement? Or would the law enforcement people also run their own UTM? And how do they know who is telling the truth? What if the UTM themselves are compromised, right? So we don't have an answer to every question here. What we can share is that in the product that we build and moving forward, and with our partnership with some of the mobile network operators, we actually propose that all this remote ID, if you're going to do the net-based remote ID, it should be done through a private APN, which is basically a network that behaves like you can't just connect to any. It's basically to have a private set of SIM cards basically that will allow the drone to connect to the cloud, and essentially it kind of forms a VPN tunnel to the regulator as well as the operation center, whoever has the authority to look at the data, right? I won't go into the details of this because it goes into the mobile side of things and goes very detailed, but I'm happy to answer questions after this, right? So the product that we work closely with our partner in Singapore, Singtel, is this thing called Iot Connect Plus, which you all can take a look if you're interested. So that is the first part, which is the UAV hardware tracker. Now, if you look at what about the rest of it, right? We also have the internet connected drones itself, right? Remote ID is one that's kind of a touchy topic because it applies to everybody, but you don't have to fly internet connected drones. We have internet connected drones as in our offering, and what we do is that we allow public VPN, right? So basically, in this case, we don't do private APN because it might be too expensive. But if you still want to say, I want to have my drone stream 4G over 4G or 5G stream video, right, and so on, we do have solutions, and all our solutions are taking cybersecurity seriously, right? Because it's important that the drones that are being flown send information back securely, and especially if the drone also receives commands from the drone operation center, that the commands are really authenticated to the pilot and not any random person who then hijack the drone to fly somewhere else, right? So this is the basic architecture that's all connected by VPN. There is not the UTM is kind of out of scope for this particular product, but we can be easily integrated. There's also use cases where we push some of our software, especially the parts that requires a lot of GPU, into the mobile edge. There's something that's kind of upcoming called mobile edge computing, where the mobile network operator also wants to run like a tiny data center at the bottom of their telco towers, which is much closer to the drone to enable advanced use cases to do computer vision processing, field safe navigation, and storm control, and so on. Right. So to give you a sense of how it looks like, this is my office. You can see like it's basically a combination of UTM system on top, as well as the pilot console where they can see the live streaming of the video, the map, where are the drones flying, whether the nearby other drones flying, as well as nice video streaming that comes back into the drone operation center, right? And there are many use cases there. Now, once the data comes back to the operation center, you also have this thing, right? Because the data now starts flowing back from the devices, which you saw on the left, right, up to the the ground control stations, whether it's the app version on the ground or the command center version in the room. And then it goes up again. It goes to the cloud, it goes to fleet management systems, the different UTMs, and UTMs then send information further upstream to maybe some national FIMs or air traffic management systems. While ourselves, when we build the enterprise stuff, we have to integrate with other ERP systems, GIS systems, and so on. So the surface area for attack for a UAS in a network connected environment is actually pretty large, right? So, but the only good part is that once you come to this side of the world, it becomes familiar ground, right? So it's a typical cybersecurity standards that need to apply, right? Make sure that you harden all your interfaces, make sure you don't open ports that you're supposed to open, and so on, right? So there's a lot of collaboration here because on the left you have these devices that's actually flying out there in the sky, and something goes wrong, it falls the sky, is a mission critical, and it's a catastrophe, right? On the right side, you have the systems that traditionally, yes, use 4 nines, but sometimes the regulators ask for more nines than 4 nines. So in the case of Singapore's case, where if you're going to do beyond mission line of sight flights, for example, once you go into the medium risk and a high risk case, the design, right, of the entire UAS, not just the drone itself, needs to be able to handle what we call 1 times 10 to the power -6 per flight hour what do you call that? Safety objective. The probability of a catastrophic event should be much lower than that. So this becomes super hard to design, but at the same time, it is definitely the level that we need to go towards if you're going to enable beyond mission line of sight operations. And so to generalize that, basically all the non-flying systems that's related to the flying system as a whole, right? The aircraft as well as all the other information systems in the cloud, you need to be able to specify the reliability and availability probabilities very well. And on the flip side, the regulators should also be very, very clear about when is it good enough, because it's definitely much higher requirement than your typical, say, websites, but how much higher? Do we need to beat the banking level or even higher, and so on? There's a lot more to go into. There's another few examples of things that we go through and think through every day. For example, risk assessment, cybersecurity framework, incident response. What else are there that's currently being very well specified in the aviation world, but the moment you plug in the internet, right, you have to also put in all the best practices of internet into the same aviation regulation, because the aviation regulation governs the whole thing as a UAS, unmanned aviation aircraft system, rather than just unmanned aircraft vehicle, right? So SORA is one example. It's a pretty well adopted risk assessment framework for drones, and we are trying to understand and unpack it right now and kind of figure out how that our cybersecurity framework kind of fits inside our risk assessment for SORA. So the last part, I mean, I just kind of point out where the direction of where all this is going. And again, this is kind of a very Singapore experience, right? So in Singapore, CAS, the Civil Aviation Authority of Singapore, is very forthcoming in saying that, yes, we want to look at BVLOS, but you really you guys have to really tell me how to keep the safety of the airspace, right? So many partners, friends, competition, and so on. We all have been creating different kinds of solutions and demonstrations. This is a good picture that I think the NTU Air Traffic Management Research Institute published years back. And I don't think we have come to a final conclusion yet, but I think it's very important that we keep that open discussion on how to keep this airspace safe. Another point to kind of bring out is more towards what we are doing currently, which is we are a manufacturer of the hardware tracker, and we also have minimum software that kind of can show you where the tracks of the drones are. But we are also looking for what next on this, right? Because if the ASTM side only wants broadcast, which we can do, right? Where is the network side of the remote ID going to go towards? We are hoping that at some point there will be some acceptance on the network remote ID, especially in the crowded areas and places with good cellular connectivity. And once we have those network RID in place, we can start talking about higher order stuff, right? So an example will be, how can we work closer with law enforcement agencies rather than have them just specify what is good and what is bad, right? To actually go down and try it out, right? A different kind of frameworks on how we can deconflict. Maybe there's a emergency ambulance drone flying in the future. Maybe you have an air taxi that's actually ferrying you to the hospital. How can that deconflict with just your drone doing inspection and deconflict with the drones with just flying maybe for fun, right? For recreation and so on. So those are also very important topics, and cybersecurity will have to factor into that. And last but not least, is just kind of to again thank the PrivaSec and DroneSec for inviting me here. And I think the work that they're doing is important, which is whatever things you plan out, you have to try it, you have to audit it, you have to rehearse it. They provide this red teaming as well, which I thought was really fantastic, where they will pretend to be the adversary, and you can see whether your cybersecurity standards actually meet the level of protection you needed. And I think that's all I have for my presentation. Hope that was useful, and if there's any questions, I'm happy to answer them right now.
Yeah, terrific, Jinju. Thank you for that. And we do have a few comments and questions that we've had from various places. So I'm happy to go through that. So I might start off with this one here. And it basically says, from a privacy standpoint, if you've got a vehicle number plate, others can't find out who you are if they're public, only law enforcement. Is this the exact same concept, or does it give counter-drone and public the ability to see who you are?
Right. So I think the who in this case is a bit different. So okay, the aviation side of the world, because again, when you're looking at say the man aircraft, right? You know that this is a Singapore Airlines flight. This is what number it is, who is the captain, and so on. But that is a commercial service, right? It does not tell you, for example, let's say if you are flying a private Cessna, right, or you're flying a private plane, and so on. I think that's one side of the world, and the other side of the world, like talk about, is the closer to the land transport, where people don't really know who you are. They can just say, okay, it's a man driving the car, it's a woman driving a car. That's probably about it, right? So we have not found that balance, if I may, right? Because I think there's still many opinions that are kind of in the spectrum of gray area. On one hand, we all agree that an ID is required. So as long as we have that ID, a lot of things are enabled. But on the other hand, just having the ID might not be enough. We might need to know where exactly you are, because you're just physically so far away. I can't say like you're at the curb of not at the curb or in the middle of the road and so on. I have to say that I see that drone, and the drone is at this long altitude. And in this case, for the US for the ASTM version, you have to also report your velocity, right? And there was this final mode that was actually proposed in the standard, which is the emergency mode. Are you just flying normally, you're fine, or you're not fine? You're actually about to come down because something wrong has happened, right? So okay. I think that's the standard today, but I think the opinions are still open on whether we need a little bit more information or actually we need a little bit less information.
Yeah, makes sense. Okay. And the next question here, oh, sorry, were you finished with that one, or are you still trying to explain it?
No, I'm finished. The next one.
Great. The question says, in the example that you had of drones to dock, or the drone operating center, if a VPN or APN is compromised, does that affect the drones actually operating, or simply the information exchange from them?
Right. So the way we build it, and I don't know how other people build it, but the way we build it is that we would detect that VPN is compromised, right? So the drone will only volunteer its video streams and its telemetry to the internet, as long as the VPN is there. If it detects that the VPN is disconnected or compromised, assuming that it knows that it's compromised, right? There's some man in the middle who joined the VPN, it's a different story, right? But assume that it gets disconnected. It goes back into a bunch of fail-safes. So there's a bunch of fail-safes where it automatically finds the closest emergency landing point. For drones that are built with boxes, they will just find their landing box and goes back to the box for charging and so on. It will not continue with their mission unless all conditions that is required for cybersecurity is met. Right? So that's kind of our design. I wouldn't know that's the best design or not, but a lot of missions are abandoned that way because it could be the VPN is broken, or sometimes you just fly in the sky and there's insufficient cellular coverage, right? Because sometimes cellular coverage, they are still optimized to point at the ground, right? The radios, they're tilted in a certain way such that in the ground signals are better. So there might be places where we're flying that we do not have enough cellular coverage. And after a few seconds, actually, if you didn't reconnect with any cellular coverage, it also goes home. So similar fail-safes will be put in place basically for all these use cases.
Okay, that makes sense. And Masumi, I might get you to put the slides back on the screen. There was a question here, Jinju, about what was the CAS incident reporting scope and the military software requirements required for BVLOS that you mentioned there, if you can touch on those.
You caught me on my last slide that I didn't finish. All right, so if you go to, so basically in Singapore, there's this ANR 101 2-0, which describes the whole beyond visual line of sight operation. If you go into that document, you will be able to find references to both the military software requirements for the high-risk operation, which actually for us, we are actually not there yet. I mean, we are still dealing with the low and the medium risk, right? So that is basically one example of anything that's been specified at all about software. But when we glance through the documentations and requirements, we find that a lot of these specifications are very much based on, again, military spec, right? So imagine you have code running on a F-15, right, or something like that, and how the code needs to be written and checked and make sure that it doesn't fail and so on. It does not address the internet, because in general, I don't think anybody has specified when you have internet connected drones, what needs to be done. So I think that's still an area that in the next maybe 2 to 5 years, I think many USS supply, UTM players especially, right, they will have to kind of play that role of trying out different standards and discussing and trialing and convincing regulators that this is good enough, this is too much, and so on. For the incident reporting, this is an example of something that's more operational. So an example, all our drone flights today in Singapore, we need to have an operator permit as well as an activity permit. So as part of the activity permit framework, there will be a number to call. There will be when something doesn't happen according to whatever was planned and applied for, you must notify CS immediately and submit an incident report in 3 days. One of my biggest kind of next step of questions that I can figure out is when a cybersecurity incident happens on a drone system, but no drones are flying, is that an incident? Because all our systems in the cloud are running 24/7, like any SaaS, right? And let's say all the drones are grounded at that point, right? But it was compromised, right? Would that correspond to an incident? In banking or any other environment, that would definitely be an incident. But for aviation, it's still kind of undefined because they all often care about things when things are flying, not when things are on the ground, right? So those are just open-ended questions that we have not been able to fully address, and I'm sure there are a lot more.
Yeah, that is a really interesting point, and I'm sure we could talk about this for a lot longer because there has been UTM, compromises. There's been compromises of fleet operational software, counter drone systems, and when you think about it, it's an incident that relates to drones, but it might not necessarily affect them in the air. So that's that aviation and kind of cybersecurity worlds colliding. So makes sense. Look, Jinju, there's one last question, and I guess this one's more of a personal basis, but you talked about Flight Radar 24, and I think of FleetMon as well, about tracking all the ships and things like that. Do you visualize a potential for the public to be able to access an online or open service like that, to be able to see drones everywhere and see those identifiers? Or is this more of a private-based thing or something based on an app? What's the scope of being able to access something like that at this point?
I think at this point, we can all agree, at least if you follow kind of the FAA thinking, right? We can all agree that if we can see the drone visually, right, we should be able to know who it is. or at least the idea, basically, right? We should know that we should have an app somewhat that shows a drone appearing on the app if we can visually see it. That usually means then a few hundred meters, right? So there might not be a app at this point to say, like, to show you the whole world where all the drones are, or even the whole country, unless your country is really, really small, right? But you can definitely see everybody who is nearby you, because those are the ones that you need to know and watch out for in case they collide into you, right? Or maybe they are shooting a video of you if you don't want to because of privacy reasons, right? So if you are at home and they will hear some buzzing sound in the vicinity, you should be able to get to your phone and say, hey, there's a drone flying in my vicinity, which I did not expect, right? I want to find out what ID is that drone. That said, I do believe that for commercial operators and for military operators and so on, the guys who are not the general public, right, the general hobbyists, but people who are kind of either have a license or inducted into that kind of a environment where safe flying is mandatory, let's say, right? Because if you're doing work for flying drones for doing work, then I think you might have a little bit more access for a much larger area. Take, for example, if you're going to do a beyond visual line of sight operation, right, and you're going to deliver something from point to point B and the thing is quite far away, you actually need a very large area, right? You need to know all the drones that's operating over a very large area, right? And basically, if let's say if a BVLOS corridor, then that corridor and then maybe 100 meters out along that corridor, you actually need to know all the drones that's operating there. So given specific exemptions, I do believe that the government, especially whoever is authorizing this beyond visual line of sight operations, would have to find that kind of compromise. They cannot say that, because it's just broadcast remote ID, I will not tell you everything else. Because pilots are eventually still liable for their flights. They still decide whether to proceed their mission or not, right? So they need as much information, as much situation awareness about their situation as much as possible. So again, so the kind of summary is I don't believe there's going to be a national or global thing at this point. And I don't necessarily think that I want to know that, because the projection right now is that for every 737 or 747, you're going to have 1 million drones, right, in the next 30 years. So, but at the same time, I want to know every single flying object as much as possible in my vicinity if I'm going to be operating in a certain way.
Yeah, absolutely. Makes sense. Well, Jinju, thank you very much for coming on board with the GDSN. Appreciate you as a first-time speaker. And we're not in person anymore, so if you can put emojis or emoticons or your words of thanks to Jinju for attending, we'd appreciate that. And Jinju, we'll see you soon. So thank you and goodbye.
Bye.